Good evening, everyone. Welcome to my weekly Node-RED development live stream. Here for an hour or so of Node-RED core development. Words fail me. Welcome back if you're coming back. Hello for the first time you're watching. What are we up to tonight? So if you were following me last week or watched the YouTube replay last week, we did some work, did some work towards a pull request to allow you to select multiple wires in the editor. And through that, whilst we got it working during the last stream, there was some optimizations I wanted to have a look at. And rather than get those done in the week after the stream, I thought I'd save them for doing on tonight's live stream, as I thought it would be interesting just to have a bit of continuity of what we're working on between a couple of weeks and get stuck in. This is probably going to be the last live stream until January, pending whatever lockdowns or changes of plans may be imposed upon us. But as it stands, I'll be on Christmas break for the next couple of weeks. So let's try and finish the year with a good one. So let's get stuck in. If you're in the chat, do say hi. It's always nice to know who's watching. We've already got Soft2K, Zoramil, Hallie77 and Steve. Great to have you all back, guys. And Cliffo. Welcome back. So let's see what we're doing. No, don't go to 3000. Go to localhost 1880. Am I a bit quiet, am I? Let me check my levels. Okay. Well, I think consensus is Cliffo, maybe you need to turn your volume up a little. So where did we get to? Well, what I did do after last week's live stream is we did get a pull request raised. So if you are following along at home, pull request 3294. This has got the work we did last week in it, but I have marked it as a draft. So if you recall, what we can now do is click on a wire, and then once I press and hold either the control or the command key on Mac, I can now click on other wires to select them. Now, things like copy and paste don't do anything because it doesn't really make sense. You can't copy a link. You can't just have links floating around the place. But yeah, that is all seemingly pretty good. If we go, maybe just go back and have a look at in the pull request. I'm not going to go over again everything we did, but I think this delta summarizes a lot of what we did last time very well. Previously, we had a single variable called selected link, which was either null or pointed at the link you had selected, and we went through systematically and updated it to be selected links as an array of the links you have selected. So all these changes are basically just swapping out that logic, dealing with a single selected link versus an array of selected links. And we had to deal with some edge cases around keeping the undo history intact and changes to do with the link nodes, which I must have lurking here somewhere. Yeah, the link nodes. So as you can see here, I've managed to select both link nodes and both virtual wires and regular wires. So that's all good. So what's left to do? Why is this still a draft pull request? Well, again, I did add some comments to this pull request, and I did touch on it in the previous stream. So let's go pull up view.js, which again is kind of the heart of all of the code dealing with drawing the flow. And the way it works is basically whenever there's something to redraw in the workspace, there's a function called redraw, creatively named, which iterates over everything that might need to be redrawn. And if it's flagged as needing to be redrawn, it gets redrawn. And there's a whole bunch of optimizations in there to try and minimize the amount of work it has to do to identify what needs redrawing. Because, and why do we need it to be efficient? Well, because when you're dragging stuff around, it needs to be responsive. You really don't want there to be a lag between you moving the mouse and the node on the screen moving. So we want that code to be as crisp and as efficient as possible. So somewhere in here, there is this redraw function. And yeah, this does all the heavy lifting. So I'm just going to collapse some of it down just to help me find what we're looking for. So here you can see all the code to do with redrawing nodes, dealing with nodes reordering. So here we get down into links. So there is a third-party library we do use to help us with a lot of this work called D3. So D3 is an awesome JavaScript library for doing, well, D3, it's called D3 because it's data-driven documents. Now, I'm saying that with a little hesitation, but I'm pretty sure it's data-driven documents is why it's called D3. But essentially, it's an awesome toolkit for giving it data, and it can help you produce all sorts of visualizations in code. Yeah, Zoramel, thanks for confirming. And welcome, old Bobby Tables. Good to join. Good to see you join us. So the way this works is D3, you can give it a collection of elements in the DOM, as in objects that are in the page, and you can give it a data structure, and it will work out the mapping between the two. So here we select all of the links that have been drawn, that are in the DOM, in the structure of the page. And using D3, we map it to the active links array. So that's the list of all the links that should be there, with a function for it to map how does it identify individual links. Then we've got two cases to care about. And I'm just collapsing a bit of code just to bring us down here, just to explain it. So link is now this D3 object that knows about what's currently in the page, and it knows about the data that we're trying to represent. We do two things. One is we call the enter function. That gives us a set of data elements that exist in the data we've got, but do not exist in the DOM. So these are new things. They have entered the collection that we care about. So you can see here, for every link in the enter set, we insert a new group. We basically start adding that link to the page. We then iterate over all of those links, and we do this code, and this code actually creates the wire. All the various aspects of, because each wire is actually made up of 3 paths, 1, 2, and 3, which again I'm sure I've shown some of before. If I bring up, yeah, so you can see here's a link, and there are 3 paths. There's a background, which if I just fiddle with these, so we've got the background, which is this really fat wire. We've got an outline, which, how easy was that be to show up? Can you just, does that work? Yeah, you can probably just make out. It is literally just this outside edge of the wire. And then we've got the wire that you actually see in the heart of all of that. Yeah, so. And the reason we have 3 is, well, the reason we've got this fat background one is that that's the one that actually catches the mouse events. It means you don't have to, for our relatively thin wires, you can actually click some way off the wire and it will still select the wire. It just makes it easier to select. Anyway, point being, each link is made up of 3 paths, which is all constructed here. And after we iterate over the link enter set, we do the opposite. So we call the exit function. And so that will give us the list of everything that we've got on the DOM, but no longer appears in our data structure. And all we have to do is just call remove, basically take them off the page because they no longer exist. So, when you delete something, that's what's happening there. Then, for all of those links, we then iterate over them again, and this is what's doing some updates, works out, has the has either end of the link moved. Oh, that's quite funky. You can see the dash effect exaggerated. Then, so this is it. Iterates over all the links. Ignore this, except this is what we are going to focus on in a sec. But it checks the dirty nodes array, which is an object. That's an object of all the nodes that have changed in some way through this loop of redrawing. So if either the source or the target of the link has changed, which might not just be position, it could be the size, it could be the size, width, height, whatever. But something's happened to it, so we better recalculate and see if we have to redraw the path. And that's what this code down here is doing, is it goes and calls generate link path given the coordinates of the nodes at either end, and updates the path attribute of those 3 components of the wire. And so that's all the work it has to do every single time it does a redraw. Every time anything moves, it's got to do all of that work for everything. Reblaw, welcome back. Mr. Walicki, good to say hi. Happy holidays to you. Long time no see. So Nathaniel's here as well. Everyone's here. Awesome. So anyway, that's all a flavour of all the work we have to do every time we redraw, every time anything moves, every time any status updates. That's all the work that has to happen. So I guess the point I'm trying to get across is you can hopefully see why we want to try and be pretty optimal to minimise needless work. So we only want to do the work we really have to do. So there's now this is funny because having said all of that, right, so bear in mind everything I've just said, what this if block is doing. This if block is recalculating the path of the wire. And this is the bit of code we added last week. We replaced. Before this was just checking whether that singleton selected link was null or not. And we've replaced that with checking this array of selected links. Does it include the link we're currently iterating over? And at the time I flagged that as being, well, that's very inefficient because if you have lots of links selected, then we are iterating over that whole array for every link to check whether it's selected or not. And it would be much better to make that a direct lookup rather than something that has to iterate over a data structure. Which all sounds good, but by taking the time to talk through what all this code is doing, this is being done in this if statement, which guards the block around recalculating the path. And whether the link is selected or not has absolutely no bearing on the path. So in fact, having that there at all is doing nothing. And if anything, is causing even more needless work, because it would be if we select, whenever we select, no, let me just refresh to get my link wires back to how they should be. Because if we select a wire, then it was recalculating its path when there's absolutely no need to. So in fact, we can remove that includes altogether, because what does care about is it selected or not is this line down here. Because it's this line down here that toggles whether the link has the selected CSS class or not. Which is entirely independent of the nodes being moved. So yeah, so here you can see we've still got a selected links.includes statement. So we still want to try and improve matters. What I'm intrigued by is this d.selected. So d in all of this is the datum. It's the for each iteration, d is the link, the data structure for the particular link we're looking at. And you can see it's got this selected property, which I'm intrigued by, because I can't think off the top of my head, why have we got two different ways that a link could be selected? Now, I have a suspicion, but I want to spend a few minutes tracking that down. Why could a link have this selected property set? Now, this could be slightly tricky to track down. And as I feared, okay, well, look, if I just do a simple search for .selected, because we want to try and find someone who's setting that property, we've got 90 results in this one file. Like I said, it's like almost 6,000 lines, this file. So, okay, we've got 90 hits for .selected. We can narrow that down. Let's look for selected followed by a space, because there might be other properties like selected foo or selected bar or whatever it might be. Add a space, we're down to 56. Still not ideal. What we actually care about is someone who's setting that property. So let's stick an equals in, and we're down to 45. Now, there might be some equality testing going on, so we only want a single equals. Okay, that hasn't got rid of any. Oops. Oh, no, I've lost them all. Right, selected equals. So we're down to 45. Not as I was hoping to whittle it down a bit further, but 45. Well, we've halved. Let's see. We might be able to cheat actually. So, because selected is also the property we use on nodes. If I do regular expression checking, quite often, if we're talking about nodes, then the property is called n, or like here you can see nn. So if we search for everything that isn't an n dot selected, we're down to 29. So let's have a look. What are we getting? P. Okay. Well, that's groups. Well, we don't care about groups. So let's forget about group.selected, and we're down to 22. Oops. Why has it done that? Right. Try again. Not N and P. Yeah, down to 22. Oh, and we don't want G either because that's for groups. So we're down to 16. Right. Status. Is it? And my worry is we accidentally filter out too much. But okay, we're down to 14 possible matches. Oh, look, a bracket. Let's throw in a bracket. That only gets rid of one more match. Oh, node. Well, we can filter on E. So we're down to 5 matches now. So D.selected. Now, as I mentioned, D gets used a lot when we're inside D3 function handlers, D representing the data, which could be a link, it could be a node, it could be a group. So we can't filter out Ds. Ds we do have to have a proper look at. So in this instance, we're setting D.selected, but what function are we in? And what is D? We're in node mouse down, D. So you've clicked on a node. So in this instance, D will be a node, not a link. So we're not interested. That's its partner. Come down here and we're on C node, connected nodes. So again, this is about selecting nodes. Well, that's commented out, so we can ignore that. That's C nodes, that's again connected nodes. And we've wrapped. Darn, we've failed to identify anything to do with setting links. Okay. That was admittedly a bit of a long shot. So the other way we could tackle this is put an if statement down here. If D.selected, we'll print out what D is. So if we can't find who's setting it, what we can do is see if we are able to do something in the editor. So I'm just trying out a whole bunch of stuff. Ooh. Ah, that's a bit of debug from last week, which is still lurking. We should definitely take a look at that in a sec. Yeah, so what we're looking for is, can we find something that causes it selected to get set on a link? So dropping a node to cause it to splice hasn't done it, which I thought it might. If I control click on there and do function, nope, that's not done it. We can detach wires, that's not done it. We can wire, that's not done it. Wire that way, that's not done it. Could be link nodes. So let's add in another link out node. That's not done it. No. Yeah, okay, what other actions could we do that might cause a link to get selected? Let's have a think. Whilst I come in here and see what this person is doing. Let's remove the spammer. Yeah, I've removed the spammer. I haven't found a way just to delete messages. I can find a way to ban people, but not to delete their messages. So it feels a little heavy-handed, but oh well. Yeah, what else can we do to... what else might set the selected property on a link? I'm not sure. So the other interesting way of looking at this would be, let's go and have a look. Go look at view.js on GitHub. Then where were we? Line about 4.3. Oop. Just give you all a sneak preview of Flowforge there by mistake. Haha. Let's go. Right, let's try and do this without. There we are. We want to go to line 4,000. I say it's ridiculously big. No, what we want to do is go to the git blame view. It's probably quicker to do it on the command line, but do it this way. So we were about line 4,300 and something. So here, this line, which has a reference to d.selected, hasn't changed for 7 years. Look at that. That's like well, it's less than so. I was going to say that's confusing. Yeah. Let's have a look at view the blame prior to this one. At which point this file is only 2,000 lines long. So let's find. Yeah, so even then, here, link selected is either the selected node or d.selected. So we've had references for d.selected being a valid thing for a link since got to start somewhere. And you know what's special about got to start somewhere? That is the very first public commit of Node-RED. So yeah, the fact that d.selected works is an artifact of Node-RED going back 8, almost 9 years. Okay, so that tells me a lot, actually. That tells me it isn't something that crept in as a side effect of link nodes or any feature that has been added in the past 8 years. It's in fact, if we just search for .selected, node selected, I'm just doing a super quick scan through. Yeah, see, all of this is all of that is to do with nodes. So what does that tell us? Well, that tells us that that selected property could actually be more useful, as in we could actually start making proper use of it. It would be so much neater to have this selected property work. But to do that, we need to update the selected property of links to keep it up to date with selected links. So let me just think about how we're going to do this. What we're going to do, we're going to do a similar things we did for moving set. So moving set used to be an array, just like selected links is, and it represents all of the nodes that are currently selected. But not too long ago, last year, earlier this year, I don't know, in the last year, I changed moving set to be an internal data structure with a bunch of standard functions for adding, removing, clearing, because it did the extra bit of work needed to keep the rest of the world in sync. So we could do a similar thing for selected links. And I think, in fact, we are going to do a similar thing for selected links. So let's redefine selected links down here. So what we're going to do is that going to be the way to do it? Is that what I've done for move and set? Yeah. So we're going to define on selected links an add function. And when we add a link, we just add it to our set of links. And we will, what will we do? If we're selecting it, then we want to set link.selected equals true. We're going to add remove. Links dot, what is it? Delete. Link, and then link dot selected is false. We're going to add clear. So what we want to do here is clear out our data structures. But, and this is probably the main reason I'm creating this custom object, because there's a few places down below where we just reinitialize selected links to an empty array in quite a few places. But for all of those places, we can't now just do it. Not only do we have to empty the array, but we've got to clear the selected property on all the currently selected links. So we're going to do that. So that's why I want this data structure, to make that much easier. Yeah, make it a one-liner in all those other places. So what we're going to do is, let me think through what's the most, we want to iterate over the set. Is that what we want to do? Doesn't need to consider undo history. All of the undo history stuff should happen outside. We've already got the logic for that, but we'll come to that in a minute. Yeah, we just want to iterate over the... Yeah, and okay, Monday evening programming brain. Iterate over set contents. Thing of, always just double check. Yeah, it's going to trip at Internet Explorer, and I know it always sounds funny. I know I've said this before, but we'll use for each instead. So we can do links.forEach link.selected equals false. And then we, in fact, we're not going to create a new set. We're going to do links.clear. Okay, and then I suspect we're going to need a couple other functions. Because sometimes order is important. You know what? Let's not get ahead of ourselves. So selected links is now this object with an add, remove, and clear function, and we have 30 more references to selected links to go and update. So, in fact, we can do a bulk update wherever we set selected links back. Let's get rid of regex matching. Wherever we set selected links to an empty array, we can do selected links.clear. Replace all them. Okay, 31 to do. Length. Okay, so we need to add a length property. So let's go back up to our implementation. And length is probably the right thing to call it. And we're going to return links dot, here's its size. And its size is it a function or is it a property? Yeah, it's just a property. Is that right? Yeah. So let's search for selected links dot length. 10 of them. We're going to replace with selected links dot length as now a function call. Done. Okay. So selected links dot clear, selected links dot length. So here we've got a for each. So we want to be able to iterate over selected links. So in fact, it is very set-like. Oh yeah, but this is the key thing. Basically we've put a wrapper around a standard set because we need to do this extra work of setting selected to true and false. But we need a for each. And we just delegate. Well, we just push that down. Is that right? Links. Yeah, that should do it. Right. Select links.clear.length for each .clear .length for each .length for each clear. Right, so here's that console.log that we stumbled over. We're going to come back to that. Here we've got where we just want to set selected links to this single link. So we can't do it in one line, but we can do it in two. So we clear it and then we add in the one we wanted. .clear, .length, .index of. All right. So this is removing. All of this logic is to do with removing a selected link. So what we're going to do is we don't need to get the link index because we don't need to splice an array anymore. But we did have a bit of odd logic here to do with lengths of stuff. And in fact, here you can see we want to be able to access, if the length is 1, we want to be able to access the first entry. Okay, it's a little bit, oh, in fact here, selected links.push, we don't want to push, we want to add. So this is to do with toggling the selected state. What we're going to say is we're going to rewrite this using some functions we don't have yet. And again, being consistent with the set API, we're going to say selected links.has mouse down link. In fact, it's the opposite case. If it doesn't have it, then we want to add it. Otherwise, if the length is not equal to 1, which is to say this this made sense at the time. I'm just going to stick with, we know this is the logic sound, we're just updating it. So we need to go and implement a has function. And we're on line 3394, because we've got to come back here in a minute. So let's implement has. And again, we're just mapping straight through. And old Bobby Tables, thank you very much. 3394, back we come. In fact, I'm going to skip over this one for the moment and we'll come back to it. I just want to see, we're just going to do the other quote unquote easy cases. Select links, so a clear followed by an add. Dot length, check. Okay. Select links dot includes. Well, funnily enough, we have that now. We could do select links dot has, which would be a order n lookup and wouldn't care about the selected property, but all of this is to move to just getting the selected property being the primary source of is a link selected or not. And you may wonder why have we got double exclamation mark there. So the class list toggle function expects a Boolean value here, true or false. And if you pass in anything that isn't strictly true or strictly false, because JavaScript likes to have truthy and falsy values and map things all over the place. If a link doesn't have the selected property set, it's implicitly false, but we have to be explicit. We have to make sure we pass in true or false, not undefined, not null, nothing like that. So the double exclamation mark, obviously a single exclamation mark would negate it, so undefined would become true, and then we negate it again, true becomes false. So it just coerces it into definitely being a Boolean. Okay, selected links dot length. Okay, oh, here we have another. Right. Here we've got two great things. So this is inside the function that returns what's currently selected. And you can see we had a to-do to clone the array because at the moment we were passing back the raw array of selected links. And we don't want to do that because we don't want to let people calling this function being able to directly manipulate intentionally or accidentally that array. So again, we've got this, we'll do it, if we do it this way round, we'll fix one problem then the other. So we're going to add a toArray function, and then we can just return, grab the first element from that array. So far we've got to implement has. Did we implement has? I think we did implement has. We've got to implement toArray. That's what we've got to implement. Oh, and we've wrapped. So yeah, there's has. So let's do toArray. And I think we can just array from links. That should do the right thing. We'll test it in a minute. So we did have here if selected links. This is to do with, oh yes, if you've only got one wire selected and you control click on it, it shows the quick add dialog. And what we were doing before was, if you, that checks we've only got one thing selected, and that was checking that you have clicked on the thing that was selected. Well, we can't do this array reference to look it up, but what we can say, we can use our has function. So we're saying selected links only has one thing in it, and it has mouse down link. So ergo, we've clicked on a selected link. And I think we're done. So just searching, we've got no more selected links, square bracket. We've got only one selected links equals, which is where we initialize at the top. So we've got rid of everywhere where we're resetting it. We've got right. We've got, if you look at the search results, we've got 31 instances of the word selected links. If I add a dot, we've now got 29. So we've got 29 instances of calling functions on selected links, which means we've got 2 places where we don't do that. And I just want to, one will be where it's initialized. I just want to double check what the other is. So we want to look for selected links followed by something that's not a dot, where it gets initialized, and a to-do list, a to-do item. Cool. So I'm pretty sure if we go and reload, everything should just still work. So we can select, I mean, what we do want to just play around a little. We can select multiple, we can delete, we can Control Z, and they all come back. We can, oh yeah, that's the test. If I Control click on a single wire, the quick add pops up. If I Control click on this one over here, it doesn't. And if I Control click on the selected one, the quick add pops up. So that's all working. Yeah, I think we're good. What we're not, well, the last remaining to do is when I wire those two together, no, that didn't do it. We've got, now, because we saw it earlier when we were playing around, I'm trying to get back to, it's when quick joining mode is on. So quick join mode is when, rather than drag, you control click on a port, control click over here. So, web tables, was that a control click on a link node wire that showed the quick add? That should not be allowed. Ooh, was it? Well, it wasn't in that oh, Bobby Tables, good spot, that man. Yeah, you don't want to be able to stick a function node. No, I don't want you to be able to stick a function node. I'm sure some of you would love to be able to magically hang nodes on virtual wires, but no. Okay, let's go fix that. So where were we? We were, well, it's one of these 31 cases. In fact, it was one of the ones we used selectlinks.has. Here we are. Yeah, so this is the logic that fires up the quick add dialog when you control click on a wire. And we only want to do this if not, because I think the virtual links have this link property set. Let's test that. So control click, yeah, see it doesn't bring up the dialog now. Control click, cool. But if I control click on this one, it does bring up the dialog because you're allowed to stick a function node in between those. Oh, Bobby Tables, thank you for spotting that. Yeah. But where were we? We were, at that moment, we were trying to work out what's... So we're in quick add mode. I've got the control key pressed, my hand's off the mouse, and I click on this node, and you can see with control still pressed, it's sort of added the virtual wire, and it's jumped on, and it's added the next wire ready for me to wire it. Look at these wires. Look at these wires. They've gone virtual. They shouldn't be virtual. That's curious. Is that related to... Have we got to the bottom of what we were... Have we got to... Have we just recreated the bug that by commenting that line out has introduced? So what it was doing was setting selected link to this select link. Let's... but select link might be null, so... What we're going to do is, oh, edge cases abound here. What I want is another link in node. Delete its wire. So with that link selected, we're going to do a quick add on this guy. Dotted follow-on wires don't occur in current master. Awesome. That's good to know, Steve, because it's, again, this is one of those weird edge cases that you'd hope wouldn't have broken. As in, wouldn't have broken by fixing other stuff. Clearly, with this commented out, this line has broken it. So what we want to do is, if select link exists, right, let's just think this through. What this line of code, as it was before, was it setting selected link and the mouse down link to this thing called select link. Select link is coming up, is being set further up here when we've decided we're adding a select link, a virtual link, but it could also be null, because we're selecting regular nodes, wiring, words fell. We're creating regular links between regular nodes. So this sort of does double duty in that by setting that to null, it deselects it, or it selects it. But we can't do that sort of double duty now. We've got to do it properly. So if select link, what we want to do is say selected links dot clear selected link dot add select link. Okay, and then, but we also need the else case now, where we do select links dot clear. And yes, there's a typo there. Okay. So I think semantically that's the same as the code that was commented out. Let's see if it's made a difference. So I'm just going to delete that wire to begin with. So control click, And, oh no. Okay. These links are still showing up. Let's have a closer look at them. If we call red.view.selection, you can see we've got our links property. In fact, we're going to just look at link. Select true. See, I was not. Oh, am I? Complete red herring. I'm wiring in a disabled node, and links to a disabled node get dashed. Oh. If I re-enable that node, the wires are whole again. If I undo it, yeah. So let's just confirm. Control click, and then let's go up to this guy. And yes, it's a solid wire. Anyway, semantically, the code I've added there is good, and I'm going to leave it there because that is a proper translation of the logic that was there, and given I can't quite rationalize well enough to say is that needed or not, I'm going to err on the side of caution and say, well, that code was there doing something, so that is semantically the same code that was there before, and not going to go down rabbit holes of the outbound wire. So yeah, was it? If I re-enable the node, no, it goes solid. What, Clifford, you may have missed, I hit Control Z to re-disable the node, which would have made it go dashed again. So I think we're good. Okay. I think we're pretty much there. We've done some good stuff. The hour's up. I'm not going to overrun because I'm not overrunning. So I think we're good, guys. We've not broken anything. We've introduced a new data structure inside the view to handle tracking the selected links. That will also be nice in the future, possibly when you want to do lasso selection or selection with groups. It just feels nice to have a clean API rather than just raw arrays and raw objects. Now, all the logic around selecting and deselecting wires is here in this one data structure, same as I've got for selecting, deselecting nodes, and that that does just feel cleaner, and gives us more. One of the risks of having lots of these just random arrays of stuff is you lose track of what semantically it all means, and sometimes wrapping it as a bit more of a data structure where you can build in a bit more logic around adding and removing from that data structure. When you need a bit more logic, then then that's goodness. Now, the irony being the fact we've changed this data structure into a set means we probably didn't need to do this selected true and false, because we could just do away with all this and just say selected links is a new set, and then rather than test link.selected, we test selected links.has. I'm now in two minds whether just to delete all of this and just replace it with a vanilla set. But no, I'm going to leave it like that. like I say, there's something appealing about having a data structure that if we wanted to build in a bit more logic around when things are selected, if there were side effects to things being selected that we needed to track, then we have it. Yeah, I think that will do us. I think that will do. So we've got rid of all the console.logs. We've fixed, thanks to old Bobby tables, the bug of quick adding, splicing a node into the middle of a virtual wire. And we've improved the efficiency of redrawing the graph to a degree that I'm pretty certain no one would be able to detect. But it always feels good to shave off those little bits of inefficiencies. Yeah. Cool. So let's finish this out. Finish off, as I say, probably the last stream of the year. Let us go and say commit the view. Just a quick scan through. Got rid of that to do. That's good. Got rid of another to do. I saw fly by. Got rid of console.log. Always good to get rid of console.logs. And we're going to commit this, and we're going to say replace selected links array with with wrapped set object. Call it a set object. Commit it. We've already got the pull request on this branch, so I don't need to create a new pull request or anything. I can just push to that branch, go and check the pull request, refresh it. We've now got our three commits. Where did we get up to 3? Yeah, oh yeah. Oh yes, there was a there was a little bug in the code we had last week, which is fine. It's fixed. So that's all good. Let's edit. Going to I'm sure there's a more efficient. I could just delete the comment, but now updated to user set to track selected links, allowing for more efficient selected test in redraw function. Update comment. Oh, there's me trying to be smart and do this strike through. Why's that gone wrong? Oh, is it just 2 then? Oh yeah. 3 tilde symbols is just force of habit from writing Markdown. We just want the ones to strike it all out. Awesome. Update the comment. Now we can mark this pull request as ready for review. It's not draft anymore. And we'll get that merged in for 2.2 coming at the end of January. And I think we're going to call it there. Just look at our issue list. Oh, yeah. Well. Yeah, there's a few bugs we could look at in future streams, or I may knock off, or indeed, if you're interested in getting involved, I do occasionally remember to label issues as good first issue. So if you're at all inspired, do have a look for those. Give us a ping on Slack or somewhere just to say, oh, I fancy having a look at that one. And I'd be more than happy for people to have a look. There's, a few on need triage that need some tidy up. So yeah, no shortage of stuff to do, which is good. That's how we like it, to a degree. It's all fun. So with that, I'm going to say thank you all for joining in yet again an hour or so of me mumbling to myself as I try and fix my own bugs. It's always great to see you in the chat. Old Bobby Tables spotted a bug, and that makes it even better. I hope you all have a great end of year. Thank you for those of you who've been joining throughout this year, and well, yeah, I've been doing these live streams now since April or so last year. Hope you all have a great holiday. Like I said, I don't plan to live stream now until early January. I'll update the schedule on Twitch. If plans change, and I'll do an impromptu one, but who knows? Otherwise, have a great holiday. Stay safe, stay happy, and I will see you in the new year, which it's still, how is it December? It's almost a new year. Anyway, good night all.